Blaise Pascal was a towering intellectual figure of the 17th century, whose contributions to mathematics, physics, philosophy, and theology continue to shape modern thought. His name is immortalized in various scientific and philosophical domains, reflecting the depth and breadth of his intellect. Although his life was tragically short, Pascal's legacy endures through his groundbreaking discoveries and thought-provoking writings. His ability to bridge the gap between reason and faith, science and spirituality, makes him one of the most remarkable polymaths in history. Born in 1623 in Clermont-Ferrand, France, Pascal displayed extraordinary intellectual abilities from a young age. His early years were marked by a relentless pursuit of knowledge. Guided by his father, Etienne Pascal, a well-respected mathematician and government official. Unlike most children of his time, Pascal did not receive a conventional education. Instead, his father adopted an unconventional approach, focusing on self-learning and problem-solving. This method proved to be highly effective, as young Pascal exhibited an astonishing grasp of complex mathematical concepts well before adulthood. Pascal's legacy in mathematics is particularly profound. He made significant contributions to probability theory, a branch of mathematics that influences various fields today, including economics, finance, and computer science. His correspondence with Pierre de Fermat laid the foundation for probability theory, revolutionizing the way uncertainties are calculated and understood. Furthermore, Pascal's triangle, a systematic arrangement of binomial coefficients, remains a fundamental concept in combinatorial mathematics. These contributions cemented his reputation as one of the great mathematical minds of his era. Beyond mathematics, Pascal made remarkable strides in physics. His studies on fluid mechanics and pressure led to the formulation of Pascal's law, which describes how pressure applied to a confined fluid is transmitted uniformly in all directions. This principle became the basis for numerous engineering applications, including hydraulic systems that power modern machinery. Additionally, Pascal's experiments on the existence of a vacuum challenged Aristotelian physics, which had long held that a vacuum could not exist in nature. His work not only advanced scientific understanding, but also demonstrated the power of experimental inquiry. Despite his impressive scientific achievements, Pascal's life took a dramatic turn when he experienced a profound religious awakening. A near-fatal accident in 1654 led him to reconsider the meaning of life and dedicate himself to theology and philosophy. This spiritual transformation redirected his intellectual pursuits toward religious and philosophical writings, culminating in Pensées, a collection of reflections on faith, reason, and human existence. His wager argument, which posits that belief in God is the most rational choice given the potential consequences, remains one of the most discussed philosophical propositions in history. Pascal's ability to navigate both the scientific and theological realms is what makes his legacy so unique. Unlike many of his contemporaries, who saw science and faith as incompatible, Pascal argued that they could coexist. He believed that reason had limits and that faith was necessary to grasp certain truths beyond human comprehension. This perspective influenced later philosophers and theologians, shaping debates on the relationship between science and religion that persist to this day. Another remarkable aspect of Pascal's legacy is his contribution to the development of mechanical computing. In an effort to assist his father with complex tax calculations, Pascal designed the Pascaline, one of the earliest mechanical calculators. Although it had limitations and did not achieve widespread commercial success, it laid the groundwork for later developments in computing. His pioneering efforts foreshadowed the digital age, where mechanical and electronic computing devices now form the backbone of modern technology. Pascal's intellectual journey was marked by both triumph and struggle. His intense devotion to study and contemplation took a toll on his health, and he suffered from chronic illness throughout his life. Nevertheless, he remained dedicated to his work until his final days. His ability to produce profound scientific and philosophical insights, despite his physical ailments, is a testament to his resilience and determination. Today, Pascal's name is honored in multiple ways. The unit of pressure, the Pascal PA, pays tribute to his contributions to physics, while Pascal's triangle continues to be a fundamental tool in mathematics. His ideas on probability theory influence everything from statistical analysis to game theory. Moreover, his theological reflections continue to be studied by philosophers, theologians, and scholars, proving that his intellectual influence transcends time. Blaise Pascal's legacy is one of brilliance, versatility, and intellectual depth. Whether in the realm of mathematics, physics, philosophy, or theology, his contributions have left an indelible mark on human knowledge. His ability to merge scientific rigor with profound philosophical inquiry makes him one of history's most extraordinary thinkers. Even centuries after his death, his work remains relevant, inspiring new generations to explore the intersections of reason, faith, and discovery. Blaise Pascal was born on June 19, 1623, in Clermont-Ferrand, France, into a family of intellectual and social prominence. His father, Etienne Pascal, was a respected magistrate and mathematician, while his mother, Antoinette Begon, came from a well-established bourgeois family. However, Pascal's early childhood was marked by tragedy, as his mother passed away when he was just 3 years old. This loss profoundly affected the Pascal family, especially Blaise, who developed a close bond with his father and sisters, particularly Jacqueline, who later became a significant influence in his life. Etienne Pascal, recognizing his son's exceptional intelligence, decided to oversee Blaise's education personally rather than sending him to a traditional school. This decision was driven by Etienne's belief in a rigorous and self-directed learning process that would allow his son to cultivate deep analytical thinking. Despite his own mathematical expertise, Etienne initially forbade Blaise from studying mathematics, fearing that it would distract him from classical studies in Latin and Greek. However, young Blaise's curiosity proved insatiable, and he independently derived mathematical principles, astonishing his father with his ability to formulate geometric theories at the age of 12. Realizing his son's natural talent, Etienne eventually allowed him to study mathematics formally, providing him with a copy of Euclid's Elements. Pascal quickly mastered the text and began formulating his own mathematical theories. By the age of 16, he had written a treatise on projective geometry, later known as the Essay on Conic Sections. This work introduced what is now called Pascal's theorem, a fundamental principle in projective geometry. His early achievements attracted the attention of leading mathematicians of the time, including Marin Mersenne, who became a mentor and introduced him to the intellectual circles of Paris. Beyond mathematics, Pascal's education was broad and deeply intellectual. His father ensured that he was well-versed in philosophy, science, and literature, instilling in him a strong foundation in critical thinking. This multidisciplinary approach allowed Pascal to develop a unique perspective that later influenced his work in multiple fields. His ability to integrate knowledge from diverse disciplines became a defining characteristic of his intellectual journey, setting him apart from many of his contemporaries. In 1638, the Pascal family faced a sudden upheaval when Etienne fell into political disfavor due to his opposition to new taxation policies. As a result, he was forced into temporary exile from Paris, leaving his children in the care of family friends. During this period, Jacqueline, Pascal's sister, gained recognition as a talented poet and playwright, drawing the attention of Cardinal Richelieu. Her growing literary reputation helped the Pascal family regain favor, leading to Etienne's return to Paris in 1639. This episode not only shaped the family's future, but also exposed Blaise to the intersection of politics, intellectual life, and religious authority, elements that would later influence his philosophical and theological writings. Shortly after their return to Paris, Pascal began working on practical applications of mathematics and physics. His father had been appointed as a tax commissioner in Rouen, and Blaise sought to assist him in his duties. This led to his invention of the Pascaline, an early mechanical calculator designed to simplify complex tax calculations. The device, though revolutionary for its time, faced technical and economic challenges, limiting its widespread adoption. Nevertheless, it demonstrated Pascal's inventive genius and his ability to apply theoretical knowledge to real-world problems. During his early years, Pascal also developed a keen interest in the emerging field of experimental science. He conducted studies on the behavior of fluids and atmospheric pressure, inspired by the work of Evangelista Torricelli. His experiments on the vacuum, controversial at the time, challenged the prevailing Aristotelian view that nature abhorred a vacuum. These investigations not only established foundational principles in physics, but also reflected Pascal's methodological approach, reliance on empirical evidence, and rigorous experimentation. Despite his scientific achievements, Pascal's early education was not solely centered on mathematics and physics. He was also deeply engaged with philosophical and theological questions, particularly concerning the nature of human existence and the limits of reason. His intellectual curiosity led him to explore the works of Montaigne, Descartes, and the Stoic philosophers, all of whom influenced his later writings. This broad intellectual engagement foreshadowed the philosophical depth that would define Pensées and his later religious reflections. Pascal's early education laid the groundwork for his dual identity as both a scientist and a philosopher. While his mathematical and scientific contributions were groundbreaking, his ability to reflect on deeper existential questions set him apart from many of his peers. He understood that knowledge was not merely about computation and experimentation, but also about understanding the human condition. This holistic view of learning would shape the rest of his intellectual journey. By the time Pascal reached his 20s, he had already established himself as a formidable thinker, capable of original contributions to multiple fields. His early education had provided him with a strong foundation in logical reasoning, empirical research, and philosophical inquiry. These formative years were crucial in shaping the polymath he would become, a man who seamlessly blended science and faith, reason and intuition, mathematics and philosophy. Blaise Pascal's contributions to mathematics were both profound and far-reaching, influencing fields as diverse as geometry, probability, and calculus. His mathematical ingenuity was evident from an early age, as he formulated complex theories that would shape the development of modern mathematics. Pascal's ability to recognize patterns, establish relationships, and create logical frameworks made him one of the most influential mathematicians of the 17th century. His work continues to be relevant today, forming the foundation for various branches of mathematics and applied sciences. One of Pascal's earliest mathematical achievements was his work in projective geometry. At the age of 16, he wrote the essay on conic sections, in which he developed what is now known as Pascal's theorem. This theorem states that if 6 points are placed on a conic section, such as a circle or an ellipse, and connected by a hexagon, then the 3 intersection points of opposite sides will always be collinear. This discovery was groundbreaking at the time, as it extended the work of earlier mathematicians and contributed significantly to the field of geometry. In addition to his work in geometry, Pascal played a crucial role in the development of probability theory. His correspondence with Pierre de Fermat in 1654 laid the groundwork for this new field of mathematics, which sought to quantify uncertainty and predict outcomes based on numerical probabilities. The two mathematicians discussed problems related to gambling, particularly the question of how to fairly divide stakes in an unfinished game, a problem that had puzzled scholars for centuries. Their insights led to the formulation of fundamental probability principles, which remain central to statistics, economics, and decision-making theories today. Pascal's contributions to probability theory extended beyond theoretical discussions. He recognized the practical applications of probability in real-life decision-making, a perspective that later influenced his famous wager argument in philosophy. His mathematical approach to risk assessment would become a cornerstone of modern fields such as actuarial science, game theory, and financial modeling. Even today, industries ranging from insurance to artificial intelligence rely on probability-based algorithms that trace their origins back to Pascal's foundational work. Another of Pascal's remarkable contributions was the development of what is now called Pascal's triangle, a triangular array of numbers in which each entry is the sum of the two directly above it. Although versions of this triangle have been studied by earlier mathematicians in China and Persia, Pascal's detailed analysis and application solidified its importance in Western mathematics. His work on the triangle provided key insights into binomial coefficients and combinatorial mathematics, both of which are essential in algebra, calculus, and modern computer science. Pascal also made early contributions to the development of integral calculus, a field that would later be fully realized by Isaac Newton and Gottfried Wilhelm Leibniz. His work on the summation of numerical series and the calculation of areas under curves demonstrated an understanding of mathematical principles that prefigured the later advancements in calculus. While he did not formalize a complete system, his insights laid important groundwork for future mathematicians who would go on to develop this critical field. Despite his numerous achievements, Pascal's approach to mathematics was not merely theoretical. He was deeply interested in practical applications. His invention of the Pascaline, a mechanical calculator designed to perform basic arithmetic operations, demonstrated his desire to simplify calculations for practical use. Though it was limited in functionality, the Pascaline was one of the earliest mechanical computing devices, paving the way for later advancements in automated calculation and, ultimately, modern computing technology. Pascal's mathematical work was also characterized by his emphasis on logic and rigor. He believed in the power of precise reasoning and clear proofs, an approach that influenced later developments in mathematical philosophy. His insistence on rigorous demonstration set a high standard for mathematical inquiry, one that would be echoed by later mathematicians such as Euler and Gauss. His legacy in this regard contributed to the formalization of mathematical proof as a fundamental component of the discipline. Despite his immense contributions, Pascal's relationship with mathematics changed over time. Following his religious conversion in the mid-1650s, he began to distance himself from purely mathematical pursuits, believing that faith and theology were of greater importance. Nevertheless, even in his later years, he continued to apply mathematical reasoning to philosophical and theological questions, illustrating the enduring influence of his mathematical mind. His ability to bridge abstract mathematics with practical and philosophical concerns remains one of his most defining characteristics. Pascal's impact on mathematics cannot be overstated. His work laid the foundation for probability theory, influenced the development of calculus, and provided essential tools for combinatorial mathematics. His ideas continue to be taught in universities, applied in technological advancements, and referenced in scientific discussions. While Pascal himself may have turned away from mathematics in his later years, his contributions endure, shaping the way humanity understands numbers, patterns, and uncertainty in both theoretical and practical contexts. In addition to his groundbreaking work in mathematics, Blaise Pascal made significant contributions to physics, particularly in the study of fluid mechanics and pressure. His experiments and theories challenged existing scientific beliefs and helped shape modern understandings of atmospheric pressure, hydraulics, and the behavior of gases and liquids. Pascal's discoveries were not only theoretical, but also practical, leading to inventions and principles that continue to be applied in engineering and technology today. One of Pascal's most influential discoveries was his work on the concept of pressure and its transmission through fluids. He formulated what is now known as Pascal's law, which states that a change in pressure applied to an enclosed fluid is transmitted undiminished to every part of the fluid and to the walls of its container. This principle has become a cornerstone of fluid mechanics and is the foundation for many modern hydraulic systems, including hydraulic presses, car brakes, and elevators. Pascal's insights into fluid dynamics revolutionized engineering, allowing for the development of machines that use fluid pressure to perform mechanical work. Pascal's experiments on atmospheric pressure were equally significant. At the time, many scientists still adhered to the Aristotelian belief that a vacuum could not exist in nature. Inspired by the work of Evangelista Torricelli, Pascal sought to test the properties of air pressure through empirical experimentation. He devised a series of experiments using mercury barometers to measure atmospheric pressure at different altitudes. His most famous experiment involved sending his brother-in-law, Florent Perrier, to the top of the Puy Dome mountain in 1648 to observe changes in mercury levels, demonstrating that atmospheric pressure decreases with altitude. This experiment provided crucial evidence supporting the idea that air has weight and exerts pressure. It also helped validate Torricelli's earlier hypothesis that a vacuum could exist above the mercury column in a barometer. Pascal's findings played a critical role in the eventual acceptance of the concept of a vacuum, paving the way for later developments in physics, including the study of gas laws by Robert Boyle and the formulation of thermodynamics in the centuries that followed. Beyond atmospheric pressure, Pascal also explored the principles of equilibrium in liquids. He investigated the relationship between pressure, depth, and density in fluids, developing theories that explained how liquids exert force in all directions. His studies helped clarify the mechanics behind buoyancy and hydrostatics, which are now fundamental to disciplines such as fluid dynamics, engineering, and naval architecture. Today, Pascal's principles are applied in everything from the design of submarines to the construction of dams and water distribution systems. Another important aspect of Pascal's work in physics was his methodological approach. Unlike many of his predecessors, Pascal emphasized the importance of controlled experimentation and empirical observation. He rejected purely theoretical speculation in favor of direct measurement and repeatable experiments. This approach aligned with the emerging scientific revolution of the 17th century, reinforcing the shift toward an evidence-based understanding of natural phenomena. His reliance on experimentation over abstract reasoning helped establish a precedent that would influence future generations of scientists. Pascal's contributions to physics also extended to practical inventions. His work on hydraulic systems led to the development of the hydraulic press, an essential machine that uses confined fluid pressure to generate force. This invention had immediate industrial applications, particularly in the fields of manufacturing and construction, and remains in widespread use today. His ability to translate scientific principles into real-world applications demonstrated his versatility as both a theoretician and an inventor. Despite the groundbreaking nature of his research, Pascal did not view science as an end in itself. Unlike some of his contemporaries, who pursued scientific inquiry purely for knowledge and progress, Pascal saw science as a tool to better understand the natural world and, ultimately, the divine order behind it. His religious beliefs played a significant role in shaping his perspective on scientific discoveries. He maintained that while science could explain physical phenomena, it could not answer deeper existential and theological questions. This belief would later influence his philosophical writings, particularly in Pensées. Pascal's work in physics had lasting consequences, influencing both his contemporaries and future scientists. His research on fluid pressure, vacuums, and hydrostatics laid the groundwork for subsequent advancements in engineering and technology. Many of the machines and systems that rely on hydraulic pressure today, from heavy construction equipment to medical devices, can trace their origins back to Pascal's insights. His contributions helped bridge the gap between abstract scientific theory and practical technological progress. Pascal's impact on physics was both theoretical and practical. His studies on fluid mechanics, atmospheric pressure, and vacuums challenged existing beliefs and advanced scientific understanding. His experiments reinforced the importance of empirical research in physics, while his inventions demonstrated the real-world applications of scientific principles. Although Pascal would later shift his focus toward philosophy and theology, his legacy in physics remains undeniable, with his discoveries continuing to shape modern science and engineering. Blaise Pascal was not only a brilliant mathematician and physicist, but also a profound writer and thinker. His literary contributions extend across philosophy, theology, and scientific discourse, reflecting his deep engagement with the intellectual and spiritual challenges of his time. Pascal's writings display a remarkable blend of logical precision and poetic eloquence, making them as compelling as they are intellectually rigorous. Through his essays, treatises, and letters, he shaped the course of Western thought and left an enduring legacy in both the scientific and literary worlds. One of Pascal's earliest literary works was the Essay on Conic Sections, 1640, which demonstrated his mathematical talent at young age. Though primarily a mathematical treatise, this work already displayed the clarity and elegance of expression that would characterize his later writings. His ability to explain complex ideas in accessible language set him apart from many of his contemporaries and contributed to the lasting impact of his works. Pascal's literary skills became more evident in his letters to Fermat, 1654, in which he engaged in a correspondence that laid the foundation for probability theory. These letters not only illustrate his mathematical genius, but also reveal his ability to articulate abstract ideas persuasively. His clear, methodical reasoning and structured argumentation became hallmarks of his writing style, elements that would later be crucial in his philosophical and theological works. A significant turning point in Pascal's literary career came with his engagement in religious controversy, particularly his defense of Jansenism. In 1656 and 1657, he wrote a series of 18 letters known as the Provincial Letters, in which he criticized the Jesuits' moral theology and defended the Jansenist movement, which emphasized human sinfulness, divine grace, and predestination. These letters were published anonymously to protect Pascal from persecution, but they quickly gained widespread recognition for their wit, rhetorical power, and incisive critique of Jesuit casuistry. In the Provincial Letters, Pascal demonstrated his mastery of satire and irony, using humor and logical argumentation to expose the inconsistencies in Jesuit reasoning. His style was direct yet elegant, blending philosophical depth with literary finesse. The letters were written in French rather than Latin, making them accessible to a broader audience and contributing to their widespread influence. They not only shaped religious debates in France, but also influenced later writers, including Voltaire, who admired Pascal's sharp wit and clarity of expression. Beyond his polemical writings, Pascal's most famous literary work is Pensées, an unfinished collection of notes and reflections on religion, philosophy, and human nature. Originally intended as a comprehensive apology for Christianity, Pensées was published posthumously in 1670 and became one of the most celebrated works in French literature. The text explores profound existential and theological questions, addressing topics such as the limits of reason, the nature of human suffering, and the role of faith in an uncertain world. One of the most famous passages in Pensées is Pascal's wager, a philosophical argument that presents belief in God as a rational choice. Pascal argues that, given the uncertainty of God's existence, it is in one's best interest to believe in him, since the potential benefits, eternal happiness, outweigh the potential losses, nothingness. This argument, rooted in probability theory and decision analysis, has been widely discussed in philosophy and remains a cornerstone of debates on faith and reason. Pascal's literary style in Pensées is unique, characterized by its fragmented structure, aphoristic reflections, and profound insights. Unlike systematic philosophical treatises, Pensées reads like a collection of personal meditations, inviting readers to engage with the text on an intimate level. The work's unfinished nature adds to its mystique, as it offers glimpses into Pascal's mind and his struggle to reconcile faith and reason. His writing is poetic, deeply introspective, and emotionally powerful, making it one of the most influential works in religious philosophy. Despite his focus on religious themes, Pascal never abandoned his scientific and mathematical rigor in his writings. Even in Pensées, he employed logical argumentation and empirical reasoning, demonstrating his belief that faith and reason are not mutually exclusive. His ability to integrate scientific thought with spiritual reflection set him apart from many of his contemporaries and contributed to the lasting appeal of his work. Pascal's literary contributions reflect his intellectual depth, rhetorical skill, and philosophical insight. Whether in his mathematical treatises, polemical letters, or theological reflections, his writing remains a model of clarity and precision. His works have influenced generations of thinkers, from philosophers and theologians to scientists and literary figures. Through his writings, Pascal transcended disciplinary boundaries, leaving a legacy that continues to shape modern thought and literature. Blaise Pascal's intellectual journey was not confined to the realms of mathematics, physics, and literature. A significant portion of his life was marked by a deep engagement with religious thought, culminating in a dramatic spiritual conversion that profoundly influenced his later works. His religious beliefs shaped his philosophical inquiries, leading him to explore the nature of faith, human existence, and divine grace. Unlike many of his contemporaries, who sought to separate reason from religious belief, Pascal endeavored to reconcile faith and intellect, offering a unique perspective that continues to be studied and debated. Pascal's interest in religion was not sudden. He had been exposed to theological discussions from an early age. His family had ties to Jansenism, a movement within Catholicism that emphasized predestination, human sinfulness, and the necessity of divine grace. Jansenist teachings stood in opposition to Jesuit doctrines, which allowed for a more lenient interpretation of salvation and free will. These religious tensions played a significant role in Pascal's later writings, particularly in his defense of Jansenist theology through the Provincial Letters. However, it was not until his personal experience of divine revelation that his religious convictions became the central focus of his life. On the night of November 23, 1654, Pascal underwent a mystical experience that he described as the Night of Fire. This moment, which he documented in a small note sewn into his coat, marked a turning point in his life. In this note, known as the Memorial, Pascal wrote about an intense and overwhelming sense of God's presence, referring to fire, certainty, and peace. The experience was so profound that he carried this note with him for the rest of his life, signifying its lasting impact on his beliefs. This moment of divine encounter reinforced his commitment to religious devotion and led him to withdraw from many of his secular pursuits. Following his conversion, Pascal devoted much of his time to theological study and religious writing. He aligned himself more closely with the Jansenist community at Port Royal, a center of religious scholarship and reform. Jansenism's emphasis on the fallen nature of humanity and the necessity of God's grace resonated deeply with Pascal's own philosophical outlook. He saw human reason as limited and insufficient to fully comprehend the divine, arguing that faith was not merely a rational choice, but a transformative experience. Pascal's religious philosophy was deeply concerned with the limitations of human reason. He acknowledged that reason was a powerful tool for scientific discovery and logical analysis, but he also believed that it had its boundaries, particularly when dealing with metaphysical and existential questions. This perspective is most clearly articulated in Pensées, where he distinguishes between the God of philosophers and the God of Abraham, Isaac, and Jacob. He criticized purely intellectual approaches to theology, arguing that belief in God was not merely a matter of logical deduction, but of personal encounter and faith. At the heart of Pascal's religious thought was the paradox of human existence. He viewed human beings as trapped between greatness and misery, capable of reason and artistic achievement, yet plagued by suffering, doubt, and mortality. This duality is a central theme in Pensées, where he describes humanity as a thinking reed, emphasizing both our intellectual capacity and our vulnerability. For Pascal, this paradox pointed to the necessity of faith, as human reason alone could not provide ultimate meaning or fulfillment. One of Pascal's most famous contributions to religious philosophy is his wager, an argument designed to persuade skeptics to believe in God. Pascal's wager does not attempt to prove God's existence, but instead presents belief as a rational bet. He argues that if God exists, belief leads to infinite gain, eternal happiness, whereas disbelief results in infinite loss, eternal suffering. If God does not exist, the believer loses nothing significant. By framing faith as a logical decision in the face of uncertainty, Pascal sought to appeal to those who relied on reason rather than revelation. However, Pascal did not view faith as merely a pragmatic choice. He believed that true belief required a transformation of the heart, not just intellectual assent. This is why his wager is not simply a mathematical proposition, but part of a broader theological argument about the nature of divine grace. He insisted that faith was a gift from God, not something that could be fully attained through human effort alone. This idea aligned with Jansenist teachings, which emphasized that salvation was granted by God's grace rather than through individual merit. Despite his religious devotion, Pascal remained aware of the complexities and struggles associated with faith. He acknowledged the doubts and anxieties that often accompany religious belief, which is why Pensées contains reflections on skepticism and uncertainty. He did not present faith as an easy or simplistic solution, but as a necessary response to the human condition. His writings continue to resonate with both believers and skeptics as they capture the intellectual and emotional tensions involved in grappling with questions of existence and divinity. Pascal's religious conversion and subsequent philosophical reflections had a profound influence on his later works and legacy. His experiences led him to explore the relationship between reason and faith, arguing that while human intellect has limitations, faith provides the ultimate answer to life's uncertainties. His writings in Pensées and the Provincial Letters remain central to religious philosophy, offering insights into the nature of belief, doubt, and divine grace. Through his work, Pascal sought to bridge the gap between the rational and the spiritual, leaving a lasting impact on theology and philosophy that continues to be studied today. Blaise Pascal's contributions to probability theory mark one of the most significant milestones in the history of mathematics. His work in this field, largely developed through correspondence with Pierre de Fermat, laid the foundation for modern probability and decision theory. Though initially driven by practical problems related to gambling, Pascal's insights into uncertainty, risk, and expected value have influenced disciplines far beyond mathematics, including economics, finance, and even artificial intelligence. The origins of Pascal's probability theory can be traced to a gambling problem presented to him by the Chevalier de Mere, a French nobleman and avid gambler. De Mere was puzzled by a particular question regarding the fair division of stakes in an unfinished game of chance. Seeking a mathematical solution, he approached Pascal, who in turn engaged Fermat in a series of letters that ultimately led to the development of probability theory. These letters, exchanged in 1654, represent the first formal exploration of probabilistic reasoning and remain a cornerstone of the field. Pascal and Fermat's solution to the problem involved breaking down the game into its possible future outcomes and assigning numerical probabilities to each scenario. This approach, known as the method of expectation, allowed them to calculate the fair value of the stakes. Their work introduced the concept of expected value, which quantifies the anticipated outcome of a probabilistic event by considering all possible results weighted by their likelihood. This principle is now fundamental in decision-making processes across various domains. One of Pascal's most important contributions was the introduction of the Pascal triangle, a triangular array of numbers where each entry represents the sum of the two numbers directly above it. Though versions of this mathematical structure had been known in China and Persia, Pascal formalized its properties and applied it to binomial expansions and combinatorial problems. The Pascal triangle became an essential tool in probability calculations, allowing for the systematic determination of coefficients in probability distributions. Beyond the Pascal triangle, his work also contributed to the law of large numbers, a principle stating that as the number of trials in a probabilistic experiment increases, the observed frequencies of outcomes converge to their expected probabilities. Though the formal statement of this law would later be fully developed by Jacob Bernoulli, Pascal's initial explorations provided key insights into the behavior of repeated random events, laying the groundwork for statistical analysis. Pascal's probability work also introduced the concept of risk assessment, an idea that would later become crucial in fields such as insurance, finance, and economics. By quantifying uncertainty and evaluating outcomes based on likelihoods, Pascal helped develop mathematical tools that would eventually be used in actuarial science and financial modeling. Today, risk management strategies in industries ranging from investment banking to healthcare can trace their origins back to Pascal's pioneering work. Furthermore, Pascal's probability theory had profound implications for philosophical and theological discourse. His famous Pascal's wager, which we discussed in the previous chapter, applies probabilistic reasoning to the question of belief in God. By weighing the infinite potential gains and losses of belief versus disbelief, Pascal introduced a novel application of mathematical expectation to existential decision-making. This argument, while controversial, remains a widely studied example of how probability theory can extend beyond mathematics into philosophy and ethics. Despite the groundbreaking nature of his work, Pascal never wrote a formal treatise on probability. His contributions were primarily documented through correspondence with Fermat and in his posthumously published writings. Nonetheless, his ideas inspired later mathematicians, including Christian Huygens, who expanded on Pascal's work in his book on the calculation of games of chance, 1657, the first formal treatise on probability. Huygens' work, in turn, influenced later figures such as Jacob Bernoulli and Pierre-Simon Laplace, both of whom further advanced probability theory into a rigorous mathematical discipline. Pascal's influence on probability extended beyond academia. His methods of analyzing uncertainty laid the foundation for the modern fields of game theory and decision theory. Concepts such as expected utility, risk analysis, and statistical inference, all fundamental to economics and behavioral science, owe much to Pascal's initial explorations. Even in modern artificial intelligence, algorithms for probabilistic reasoning, such as Bayesian networks, draw upon principles that Pascal helped establish. Pascal's work in probability theory represents one of his most enduring legacies. Though initially motivated by a gambling problem, his insights into uncertainty, expectation, and decision-making revolutionized mathematics and influenced numerous other fields. His probability work not only laid the foundation for modern statistical analysis and risk management, but also extended into philosophy and theology, demonstrating the far-reaching impact of his ideas. Today, Pascal is recognized as one of the founding figures of probability theory, and his contributions continue to shape disciplines ranging from economics to artificial intelligence. Blaise Pascal's contributions to science and engineering were as groundbreaking as his work in mathematics and philosophy. His experiments in fluid mechanics, hydrodynamics, and pressure theory laid the foundation for modern physics and engineering, influencing a wide range of fields from hydraulics to meteorology. Though he is often remembered for his work in probability theory and religious philosophy, Pascal's scientific endeavors were equally transformative, demonstrating his ability to apply mathematical reasoning to practical and experimental domains. One of Pascal's most significant contributions to science was his research on fluid pressure and atmospheric pressure. In 1646, he became interested in the work of Evangelista Torricelli, an Italian physicist who had developed the first barometer. Torricelli's experiments suggested that air pressure played a crucial role in supporting liquid columns, challenging the long-held Aristotelian belief that nature abhors a vacuum. Pascal sought to expand on this idea, conducting a series of experiments that would eventually lead to the formulation of Pascal's principle. Pascal's most famous experiment on atmospheric pressure took place in 1648 when he arranged for his brother-in-law, Florent Périer, to carry a mercury barometer up the Puy de Dôme mountain in France. As the barometer ascended, the mercury level dropped, confirming that atmospheric pressure decreases with altitude. This experiment provided decisive evidence that air pressure is not uniform, and that the weight of the air above us influences physical phenomena on Earth. His findings challenged Aristotelian physics and laid the groundwork for further studies in meteorology and fluid mechanics. Building upon these experiments, Pascal formulated Pascal's principle, which states that pressure applied to a confined fluid is transmitted equally in all directions throughout the fluid. This principle became one of the fundamental concepts of fluid mechanics and has since been applied in numerous engineering fields, particularly in hydraulic systems. Today, Pascal's principle is the basis for hydraulic presses, cart brakes, and various industrial machinery, showcasing the enduring impact of his discoveries. Pascal's contributions to engineering extended beyond fluid mechanics. He also invented one of the earliest mechanical calculators, known as the Pascaline. Motivated by his father's work as a tax collector, Pascal sought to create a device that could assist in complex arithmetic calculations. The Pascaline, developed in the 1640s, was capable of performing addition and subtraction through a system of gears and dials. Although limited in its operations compared to modern computers, it was one of the first attempts to mechanize mathematical calculations and represented a major step toward the development of computational devices. The Pascaline's design inspired future developments in mechanical computing. While it was not widely adopted due to its cost and complexity, it demonstrated the feasibility of automated computation. Later inventors, such as Gottfried Wilhelm Leibniz and Charles Babbage, built upon Pascal's work to develop more advanced mechanical computers. In this sense, Pascal's invention foreshadowed the rise of modern computing and automation, making him a pioneer in early computer engineering. Beyond his work in mechanics and computation, Pascal also made contributions to materials science and structural engineering. He studied the properties of liquids and solids, investigating how forces and pressure affected different materials. His insights into stress distribution and mechanical forces influenced later engineers and scientists working on bridge construction, fluid pipelines, and mechanical systems. Pascal's ability to blend theoretical insights with practical applications was a defining characteristic of his scientific work. Pascal's contributions to science were not merely theoretical. He was also a skilled experimentalist who emphasized the importance of empirical verification. Unlike some of his contemporaries, who relied primarily on abstract reasoning, Pascal conducted rigorous experiments to test his hypotheses. His scientific methodology aligned with the emerging principles of the scientific revolution, which emphasized observation, experimentation, and mathematical analysis. This approach placed him in the company of figures such as Galileo Galilei and Isaac Newton, whose works similarly transformed our understanding of the natural world. Moreover, Pascal's scientific investigations had philosophical implications that shaped his later theological reflections. His studies on the vacuum and pressure led him to contemplate the nature of infinity and the limitations of human understanding. He recognized that while science could explain many physical phenomena, it could not provide ultimate answers to existential and metaphysical questions. This perspective, evident in Pensées, highlights the duality of Pascal's intellectual pursuits, his simultaneous commitment to scientific inquiry and religious contemplation. Blaise Pascal's influence on science and engineering remains profound. His experiments on fluid mechanics and atmospheric pressure laid the groundwork for modern physics, while his invention of the Pascaline contributed to the evolution of computational technology. His ability to bridge mathematics, experimentation, and engineering exemplifies his genius and underscores his lasting impact on multiple disciplines. Today, Pascal's scientific principles continue to be applied in hydraulic systems, meteorology, and computing, ensuring that his legacy endures in both theoretical and applied sciences. Blaise Pascal's contributions to literature and philosophy are as profound as his work in mathematics and science. Although he lived a relatively short life, his writings had a lasting influence on the intellectual landscape of Europe, shaping discussions in theology, ethics, and existential thought. His literary genius is most evident in Pensées and the Provincial Letters, two works that continue to be studied for their rhetorical brilliance and deep philosophical insights. Pascal's literary legacy is unique in that it bridges the gap between scientific reasoning and religious faith, offering a perspective that remains relevant in contemporary debates on reason, belief, and the human condition. One of Pascal's most enduring works is Pensées, meaning thoughts, a collection of fragments and unfinished notes that he intended to compile into a comprehensive defense of Christianity. Although he did not live to complete it, Pensées remains one of the most influential works of apologetic literature in history. It presents a compelling argument for faith, not through dogmatic assertions, but through a deeply personal and intellectual exploration of human nature. Pascal's approach was unique because he acknowledged both the greatness and misery of humanity, arguing that the contradictions in human existence point to the necessity of divine truth. A central theme in Pensées is Pascal's famous distinction between the God of philosophers and the God of Abraham, Isaac, and Jacob. He criticized purely rationalist approaches to theology, arguing that faith is not a matter of intellectual speculation, but a transformative experience that engages the heart as much as the mind. This emphasis on the emotional and existential aspects of belief prefigures later existentialist thinkers, such as Soren Kierkegaard and Friedrich Nietzsche, who also grappled with the tension between reason and faith. Pascal's argument suggests that rational proofs of God's existence, while valuable, are insufficient to inspire true commitment. Faith requires an internal, personal conviction. One of the most famous ideas in Pensées is Pascal's wager, which applies principles of probability and decision theory to the question of belief in God. Pascal argues that given the uncertainty of God's existence, the rational choice is to believe because the potential benefits, eternal happiness, far outweigh the risks of disbelief. This argument, though not a traditional proof of God's existence, has been widely discussed in philosophy, influencing debates on rationality, risk assessment, and the limits of human knowledge. Pascal's wager remains one of the most well-known philosophical arguments in religious discourse and has inspired both support and criticism from theologians, atheists, and logicians. In addition to Pensées, Pascal is also renowned for the Provincial Letters, a series of satirical and polemical writings defending Jansenism against the Jesuits. Written between 1656 and 1657, these letters showcase Pascal's literary brilliance, blending wit, irony, and rigorous argumentation to critique the moral theology of the Jesuits. His writing style in the Provincial Letters was so powerful that it influenced the development of modern French prose, earning him recognition as one of the greatest stylists in the French language. Voltaire, despite his opposition to Pascal's religious views, admired the literary quality of these letters, calling them a masterpiece of French literature. One of the key achievements of the Provincial Letters was its ability to make complex theological debates accessible to a broader audience. Pascal's clear and engaging prose allowed readers outside the scholarly world to understand and engage with intricate religious and philosophical disputes. This approach reflected his belief in the power of language as a tool for persuasion and enlightenment, a belief that shaped his broader intellectual project. By making his arguments both logical and emotionally compelling, Pascal ensured that his ideas resonated beyond the academic and theological circles of his time. Beyond the specific arguments in Pensées and the Provincial Letters, Pascal's broader philosophical legacy lies in his exploration of the human condition. He was deeply concerned with questions of suffering, mortality, and the search for meaning, themes that continue to be central to modern existential and psychological thought. His reflections on the distractions people seek to avoid thinking about death and the insignificance of human life in the vastness of the universe anticipate later philosophical developments, particularly in existentialism and absurdism. Pascal's ability to integrate scientific reasoning with profound philosophical inquiry sets him apart from many other thinkers of his time. While some philosophers sought to elevate reason above all else, Pascal recognized its limitations, arguing that some truths lie beyond human comprehension. This perspective made him a precursor to later discussions on the boundaries of knowledge, influencing thinkers such as Immanuel Kant, who similarly explored the limits of pure reason. In this way, Pascal's thought bridges the gap between rationalism and fideism, offering a nuanced view of human understanding. The literary and philosophical influence of Pascal extended well beyond his lifetime. His ideas were instrumental in shaping later theological discussions, particularly in Catholic and Protestant apologetic. His reflections on the nature of belief, doubt, and human suffering have been referenced in contemporary discussions on faith and reason. Even outside religious contexts, his exploration of uncertainty and decision-making continues to inform fields such as probability theory, psychology, and ethics. His ability to write with both intellectual rigor and emotional depth ensures that his works remain widely read and studied today. Blaise Pascal's influence on various fields, ranging from mathematics and physics to philosophy and theology, has ensured that his legacy endures long after his death. While his life was brief, his intellectual achievements have made him a towering figure in the history of thought, with his contributions continuing to shape modern science, literature, and philosophy. In this final chapter, we will explore how Pascal's work has persisted across the centuries, his place within the broader intellectual tradition, and the lasting impact he has had on future generations of thinkers and practitioners. Pascal's mathematical and scientific contributions laid the groundwork for many of the concepts that would define modern science. His work in probability theory and fluid mechanics, for example, set the stage for later developments in statistical analysis, risk management, and engineering. His formulation of Pascal's principle, which states that pressure in a fluid is transmitted equally in all directions, remains a fundamental concept in fluid dynamics and hydraulic engineering. The hydraulic press, a key invention in modern industry, relies directly on this principle. As such, Pascal's contributions have had a direct and lasting impact on technological advancements, including the development of machinery, medical devices, and even aerospace technology. Beyond these practical applications, Pascal's contributions to probability theory marked the beginning of a new approach to decision-making under uncertainty. His work laid the foundation for the development of modern decision theory and behavioral economics, fields that have shaped industries such as finance, insurance, and policymaking. Today, professionals across the globe use tools derived from Pascal's mathematical insights to assess risk and optimize strategies in the face of uncertainty. Whether through financial modeling, market predictions, or healthcare decision-making, Pascal's work in probability theory continues to be a cornerstone of modern analytical methods. In addition to his contributions to the physical sciences, Pascal's religious philosophy has had an enduring influence on theological and existential thought. His reflections on the limitations of human reason and the need for divine grace in Pensées have influenced both religious and secular thinkers. His famous wager, which argues that belief in God is a rational choice when considering the potential outcomes of faith versus disbelief, remains a classic example of philosophical reasoning applied to matters of religion. This idea has been revisited by contemporary philosophers, particularly in discussions of risk, probability, and rational choice theory. Moreover, Pascal's exploration of human suffering, the paradoxes of existence, and the limitations of human knowledge have prefigured existentialism and continue to resonate in modern debates on meaning and morality. Pascal's intellectual legacy also lies in his approach to the intersection of faith and reason. At a time when the scientific revolution was challenging traditional religious views, Pascal remained committed to integrating his religious beliefs with his scientific and mathematical work. This reconciliation of faith and reason was groundbreaking, as it argued that belief in God was not the antithesis of reason, but rather something that transcends human understanding. His work prefigured later philosophical movements, such as pragmatism, which emphasizes practical consequences and the integration of belief with action. Pascal's view that human beings are inherently caught between reason and faith, greatness and misery, has continued to inspire both philosophers and theologians who grapple with the complexities of the human experience. In the realm of literature, Pascal's Pensées and the Provincial Letters have had a lasting impact on French literature, shaping the development of the modern essay. Pascal's ability to combine intellectual rigor with literary elegance made his writings not only philosophically significant, but also stylistically influential. His incisive critiques of the Jesuits in the Provincial Letters and his existential reflections in Pensées continue to be regarded as masterpieces of French prose. Pascal's influence can be seen in the works of later writers, including Voltaire, whose philosophical writing was deeply shaped by Pascal's approach to reason and faith, and in the work of 20th-century existentialists such as Jean-Paul Sartre and Albert Camus, who expanded upon Pascal's themes of human suffering, alienation, and the search for meaning in an uncertain world. Beyond the intellectual realm, Pascal's personal life and its connection to his intellectual achievements also continue to be a source of fascination. His decision to leave behind his promising career in mathematics and physics to devote himself to religious philosophy and writing has inspired those interested in the intersection of intellectual pursuit and personal conviction. Pascal's transformation from a brilliant scientist to a deeply religious thinker serves as an example of the power of personal experience in shaping one's worldview. His writings on the nature of faith, doubt, and human vulnerability offer profound insights into the human condition, making him a figure whose influence extends far beyond academic circles. Pascal's legacy is also reflected in the continuing study and preservation of his work. Scholars continue to explore his mathematical, scientific, and philosophical writings, not only for their historical importance, but also for their relevance to contemporary issues. His work on probability theory, for example, has seen a resurgence in fields like artificial intelligence and data science, where concepts of uncertainty and prediction are central. Similarly, his religious reflections on the nature of belief and the paradoxes of existence remain central to ongoing discussions in theology and philosophy. Institutions such as the Académie des Sciences and various universities around the world continue to celebrate Pascal's contributions, ensuring that his work remains an integral part of modern intellectual culture. In the modern age, Pascal's influence extends to many disciplines, from engineering and computer science to philosophy and theology. His work on the hydraulic press and mechanical calculators, for instance, laid the groundwork for later technological innovations, including the development of the digital computer. Today's computer engineers and physicists routinely encounter the principles Pascal helped establish, whether they're designing new computational systems or exploring the physical principles of fluid dynamics. Furthermore, his exploration of human psychology and decision-making continues to inform the work of contemporary cognitive scientists, behavioral economists, and neuroscientists who study how individuals make decisions under uncertainty. Blaise Pascal's legacy remains a profound and far-reaching force in intellectual history. His groundbreaking contributions to mathematics, physics, philosophy, and literature have shaped the course of modern thought and continue to influence contemporary fields ranging from decision theory to existential philosophy. Pascal's ability to bridge the gap between the empirical world and the realm of the divine, between the rational and the irrational, ensures that his work remains relevant and influential today. Whether through his mathematical insights, his exploration of human nature, or his literary prowess, Pascal's impact continues to resonate, making him one of the most enduring figures in the history of Western thought.